Okay, so we are a little bit behind the schedule just for the fundamentals thing. So I would like just to just cover the fundamentals for today and hopefully give you a little bit uh, because after fundamental is supposed to be a function, but function I think should be faster because I also teach in calculus about functions. So I will mention and emphasize, I think, some important things that you need to consider. Okay. So after we deal with the last part is the absolute values. If you remember the last lecture, I gave you the idea of absolute value, and the meaning behind this absolute value is the distance. Okay, the distance. And then the next part will be the exponent and radical, and I will just give you quick review, just summary, just to make sure that we are on the same page. Okay. So let me just write here exponents and radicals. Okay. Now if I have a with power of n, okay. Let's say the let me write maybe here. If a is any real number and n is positive integer, then if I write a with power of n, which means we are going to multiply a with a with a with n factors. So how many times we multiply a, it depends on the n. The a we call also the base, and n is exponent. So if you want to prove, for example, I have 5 with power of 4. This means this is 5, power 5, 5, 5. And I have 5 with power of 2. This is just 5, 5. But if I want to multiply 5 with power of 4, 5 with power of 2, they simply add. We can write this multiplications 4 and then adding another 2, or we could write that this is going to be this. Okay, I hope it's still okay with you, I think, right? And of course, if we had 5 with power of negative, let's say negative 4, okay, and if we want to multiply with the 5 with power of 4, since we have this addition here, then this will be 5 with power of 0, which means going to be 1. Or if we could look at, this can be reciprocal, so 1 over 5 power 4, multiply 5 power 4, or this is just cancellation, this is just 1, okay? Just a quick review, okay? So whenever you have a with power of 0, it's just 1. When you have a with power of negative n, this will be 1 over a with power of n, reciprocal. Okay. Let me check my How about this? Oh yeah, this is true. This is some property that you can have within the exponent. So whenever you are not really sure what's happening with the exponent, one thing for sure is if you remember that the exponent is actually multiplication of the base itself, I think it's easy for you to just prove with some numbers that is within the interval or within the definition. Okay, for example, we have just 5. I think 5 is very simple number. Then it's definitely if you have 5 with n power, depends on the n. If it's an integer, it's easy to be counted for, right? Okay. And if we look at the sum of the property here, okay, this is just some example. I believe this will be coming handy for some algebra, okay, because the problem is for those of you who are still also taking calculus, some part of the calculus you need to really familiar with the algebra, and one of the algebra will be understanding the exponent. Okay. Okay, we're not going to explain every details here. Okay, I need you to just digging all this stuff by yourself. And I think this is you need. I think it's still familiar, right? Just a quick review. Okay. Okay. I think I can go to the next page. I just want to just have some quick review. All right. Now the other part is the radicals. Okay. So exponents and radicals. So when we have something like, for example, the base, let's say the base is 2. Then if we have a rational number for over 5 like that. Another way to say, if this happens, the rational happens, or the easiest one that you can think of is this 2 with power of half, which means that we are going to introduce to the radicals the square root, right? So if we have square root of a equal b, which means that b squared is equal a, and we need to have the b is at least 0. So this is the square root, okay, square root. But if we have not only the half, the rational, we have another maybe 1/3, 1/4. So let's say if we have the n is positive integer. Okay. Then the principal and root of a is defined as or meaning this will be b with power of n equal a. Then if n is even, which means 2, 4, etc., then we must have A positive and B also positive. Okay, so this is when we are going to have all the numbers within the real numbers, okay, within the real numbers. Okay, if we have something that is negative here, for example, -3, in real numbers, it not exist, right? In real numbers, not exist. But we have in the complex or imaginary number, but that will be another section. But the default for all the basic of math, the default, or even in calculus, you will be always in the real numbers, okay? Because calculus deals with the first terms is dealing with something that is tangible, something that is, you can see the visuals, the graph, all of it, meaning that the domain that you are working on basically by default is a real number. Okay. Okay, now I'm going to give you another one, the property of the and root. And again, I don't want you to rememorize this. I don't want you to memorize this. This is something that is supposedly not to be memorized, okay? This is how you can, so what I want you to do is make all these things is in your mind, all the things here, you need to make it logically make sense, okay? So for example here, the definitions for the for this, let me just write here. 2 with power of half, we can define this rational 1/2 as a square root, right? Square root. Or we could say, if we have another one here, we can define this with a cubic root, right? And so on and so forth, as long as the denominator is on the integer, okay? Or this is part of the, here, the n is positive integer. So what we have here is you can play with these roots and make it the rational exponent to prove whether it's true or not, and to prove whether this is consistently correct or not. Okay. For example, this part here, you can say that this a is 1/n, and then it's going to be 1/m like that. So we could just take multiplication and make it mn. So it's not too different from the exponent, as long as your definition at the beginning is consistent. Okay? So that's the principle. So every mathematics, every calculus mathematics part, at the beginning you will have some definition. As long as you know the definition and you make some consistency within that definition, the more you see from the top to below, you will see some consistency. Okay? You can try and you can follow some rules. Okay? But this is not something to be memorized. Okay? Okay, and the other also same thing with the others. Okay? And for the square root, because we want to make sure that this is all within the real numbers, we need to make sure that how n will be behave. Okay. Yeah, don't worry. Yeah. And of course, if n is odd, then negative will be not a problem. Okay, not a problem. Okay. So if we have -1, but this is 3, this is still -1. Okay. Okay, this is a little bit detailed, but perhaps this will be important later on. Okay. Okay, since I introduced you the rational expressions, let me just add the terms below here. Okay. Rational exponents. So a 1 over n, this will be square root a. So if we have for any rational m over n, where m and n are integers, and of course n should be greater than 0 because of the domain itself to be defined. Then definition, we define or we could say that this is the same thing. Okay. Then if n even, then a will be at least 0, which means it cannot be negative if that's even. Okay, so this is another way to say what I've explained before. Rational exponent space. So far, I think okay, or it's too slow. Can be faster. Or huh? Okay. Or do you need faster? Okay. Let's just take it easy. We have to have some few hours. Okay. Another sections that is, I think, important is rationalize the denominator. Denominator. So rationalizing means that we are going to the principle eliminate radical in denominator. So if we have like this, okay, 1 over square root of a, we say this is not a standard because they have the radicals below. So that why what we are going to do is we are going to multiply with each, okay, with the other radical. Okay. So by doing this, we are going to eliminate the radicals here. So we are going to have 1 over a and then square root of a. Okay. This is how you see. But if we were thinking that because a is square root a, you can think that if you have square root a on the top divided by a, it must be left 1 over square root a. So whenever you have seeing the square root of a and the denominator, you could directly just go to 1 over a square root of a. That's, I think, quicker. But the principle is we are going to multiply this, okay? Multiply the form with this, okay? This is what we call the standard form, okay? The standard form. Okay. Okay, that's it for the exponent and the radical. The next part will be about the algebra expressions. Okay, first is, let me write algebraic expression. So what is algebra? Okay, first we start with variable. Okay, I think you already done this many times. So, but let me just start with something very basic. What is variable? What is variable? Usually you know the x, right? You need to find the x blah 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 solution of x. But what is x actually?
Container.
You can say that, of course. But why do we need to have the variable?
Because we have a number that we need to find, so we don't know its value. So we add the x.
Yeah. Or we can say that a variable is something that is, we can start with the unknown. Okay, the unknown. So back then, when people invented algebra, they start with playing with some numbers, okay? Like you did in, I think, in maybe elementary school or maybe junior high. Maybe you can start with 2 plus 3 is 5. But then they start to, like, what is this? Oh, it should be 3, right? Okay. With something simple like this. Okay? And then they generate, from this simple variable, they generate more and more advanced, and maybe they can model something like when you deal with some physics phenomenon, you deal also with variable, something that you are going to at least evaluate. You want to know how much is it, and you need to have some model, right? You need to have some models. Okay? That's maybe for too advanced. But let me start with a simple one. Okay? So this unknown, back then, why we are so familiar with the word x. Why not a? Why it's always x? This is just a trivial question. If you know, I can give you a present. No. No. Anyone know? I know this history because I hear some TED talk about this. Why is x called x? No one know? No, no. Okay. So it's because back then, when the algebra invented, I think it's invented around the in the Middle East, and then it goes to Spain, and got Latinized in Spain. It's got Latin, but the problem is in the Middle East they use Arabic, and when they use Arabic to write this unknown, they write in their terms, it's called shine, or the unknown. But the problem is, in Spain or in Latin, they don't have the exact words or the exact letters. So they come up with x. That's why x. X is historically, or as in definition, it's something that is unknown. Okay, unknown. So why from the elementary school, junior high, we always have this x? It's from this history perspective, okay, historical perspective, okay. Okay, anyhow. And then from this variable, we can make out some expressions, like maybe the easiest one, linear expressions, like x plus 2, or maybe getting some squared here, and plus 3, or maybe square root x plus 8, and etc. We call this algebraic expression. And we know from this algebraic expression, at least we know something called polynomial. Okay, polynomial. From here, we can arrange something called polynomial. Polynomial means we have many expression, or if it's only having one terms, we call it monomial. Okay? If they have two, it's called binomial, trinomial, and so on and so forth. Okay? And in binomial, you can also have some interesting rules that set up some binomial expression, but that will be another story. But in polynomial, we can just write some generic rules or expression that we can write as many as we want. And then we need to also assume that the constant will be the real number. And n is, to define this to become true, we need to say that n is non-negative integer. If an is not equal 0, then polynomial has degree n. Okay. So why we need to say all these things, like it has some definitions? Because in mathematics, if we are not defined really precise, we will have a problem. Okay? But of course, if you deal with some questions, some problems, as long as we know, we assume the same thing, the general things, you can just find your solution directly. Okay. But as official definition, we need to make sure that we understand what this definition will be. Okay? What is the discussion about? We need to understand, right? Okay. Because math is a language that needs some rules, some precision. And of course, from this polynomial, because we can have like variation in its degree. For example, you have a quadratic, you have linear, you can have cubic, and so on and so forth. We can adding, we can subtract, as long as we add and subtract with the same degree. Okay, I hope you get that. Okay, let me move to the page. So let me write property. Just a quick review. We need to have some example, maybe later. Adding and subtraction. With the same degree, with the same degree n. Another property is multiplying algebraic expression. For example, we can multiply 2x plus 1 and 3x minus 5. I believe this should be easy. So 6x squared three x and negative 10x, and then minus 5, or okay. And from this multiplying, we can have factoring, right? We can have factoring. We can factoring. Factoring means from polynomial, or maybe later I will explain. Let me just add some terms that important in the here special product formulas. Just a review, okay? So when we multiply the polynomials, if a and b, they are all real numbers, we can have some sort of this 5 specific, we call special product formulas. Well, what I want to emphasize is although this seems to be a lot of things that need to be overview, but what I want you to emphasize is all these things is just basically start with the A. Just start with this. So multiply, multiply, and add, multiply, and add. Okay. So all the things here are practically something like that. So, for example, if we have this has a plus b squared, which means it's a plus b, a minus b squared is a minus b multiplied with a minus b. And if we have the cubic, this means, although it's going to be very long, it means that a plus b, we can say a plus b and then a plus b squared. And then by doing some multiplying product from the previous one, we can say that this is going to be, and then by doing this same multiplication, you can start and take all the possible multiplication and then add. Okay. And it turns out going to be this. Okay. Or I believe you are also familiar with the Pascal, right? It's also from there, from this triangle. And you have this. And this is also, I think, in your binomial theorem, I think, yeah. But anyhow, I will not going to be digging too much on that. Okay. Okay. Now, next thing is the factoring. Okay, I will write in the bottom here, factoring. So practically, if we have the a plus b, a minus b, we call this expansions. Or maybe let me start with the, just make it positive, all positive. This is called the expansion or expanding or expand. But when you try to reverse, this is what you call the factor, okay? Factorial. So if we have, let's say, we start with x minus 2 and x plus 2. We expand this to become x squared minus 4, right? And we say that x minus 2 and x plus 2 are factors of x squared minus 4. Okay? Now to make out this factor, there are several steps. Okay. First thing is common factors. It is just a regular equation. We are not yet discussed about function. Okay? So let me just write some equation here. Okay? If we want to know these factors, the easiest way to know is the common factors. Like we can just make out this x and maybe 3, and this will be x minus 2. So we know that this is the factors. Okay? These two are the factors. Okay? And then the other way, I believe you guys are already practically using it many times, and you have done it in a quick way, right? For example, this. The idea for the factors is we need to make out this 12 from multiplications, and we need to make out this 7x from addition or subtraction. Okay? Let me give you some tips. Okay, whenever you want to factor, maybe more complicated than this, but let me just give you this simple one. Make out the table. Okay, make out the table. And since it's just x squared, so both of this column, we just adding x. Okay. The next thing, look at this 12 and make out any vectors that the product is 12, positive 12, right? Because it's positive, it's either -3, -4, or 3 and 4, right? Let me just write with negative first. Obviously it's wrong, but let me just give this. Do some cross multiplication here, and when you add this two, it needs to be positive 7. Of course, this is going to be wrong because it's adding. You add this two, you get -7, right? We need to have plus. So the only obvious answer is this should be positive. Okay, and then you can write down x positive 3, x plus 4 as x plus 3, x plus 4, and you get the factors. This is really, really fast. Of course, if you have this x squared plus 7, x plus 12, it's easy to factor, right? You don't need to write a table. You can do that with some trial and error very fast. But when you have something that is let me just finish this and we have a break for 5 minutes. And we have this 6x. 6x, they have some possibilities, like we can have 2, 3, as long as become positive, we have 1, 6, or the counterpart with all negative, right? But let's just say we are going to have with these two possibility, okay? Or you can just choose one and then you can compare. Now the right table is going to be -5. So it's going to be 1 or -5 or -1 or 5. With this method, you cross multiply this and you can get the correct answer really quick. You can get the factors really quick. Okay, even though the first trial or maybe wrong, you can just adjust and then you can get the correct answer. Rather than you have this and then you can try some numbers. This takes your time and then you are probably making some miscalculation. Maybe you are making some miscalculation. But with this table, you know when it's wrong, and then you can adjust and then fix and then get the correct answer. So you know that we have this going to be, let's say we have 2x and 3x. Okay, And let's just say we have maybe 1 and -5. Oh, it's correct. Maybe start with the wrong answer first. We start with this. We got 10x and then -3x. It's +7. It's wrong. So maybe we can just adjust this. Make it minus this. And we get the correct answer. Really fast. I think if you do a lot of cram school a lot, you know, like there are several methods that finding the factors. Like, you know, this one that has this. If you know, but I'm not suggesting this. I'm pretty confident with just this table for factoring. Okay, I think we can have some short break for 5 minutes, 5-6 minutes. Okay. Okay. I think we can continue. Do we still have later another break, or do you want to continue and then early class and you want to have early class finish?
Sure.
Okay, so I think I will skip the break later, okay, and then continue until the end of the class. Is that okay with you? Okay. Well, I'm planning not to have like a full class until 9 p.m. I think we can, before that we can finish. Okay. So next is the some factoring formulas. What I want to emphasize here is the perfect square. Okay. This one, the perfect square. Okay. So the perfect square, or later we also know this as the complete square. We can also say this is a complete square. It's one of the a useful method, okay, later on when you learn more about the polynomial. It's one of the method to, rather than usually when you have questions about roots, you ended up with the formula for the ABC formula, right? A is finding the roots, like this formula. Right? You ended up with this, okay? But I don't want you to depend too much on this equations, okay? There are another way to find, and one way that is, I think, still doable is doing the perfect square. Whenever you have a polynomials, you can, and then you can make a standard form out of that polynomial. I think should be okay. It should be okay, unless there will be, well, the end result is it can be anything. It can be a complex number also. Okay, and then the other that is, I think, really interesting is that now is 2. Okay, the cubes. Okay, the difference and the sum of cubes. Okay, and that is quite interesting. You know how we can get this? I think later on when we deal with the polynomials, when you deal with the division, the syntactic division, you will know that how we can get the a minus b or a plus b as the formulation. Okay. Okay, to recognize the perfect square, okay, let me just give you some illustrations. Okay. For example, if you have x squared plus 6x plus 9. Okay. Now the perfect square, because you know that it came from, let's say, let me just write this a squared. Okay. Or let me write a plus b squared is equal a squared plus 2ab plus b squared. Okay. And then let me just write with some, maybe 1, just to see what does this make it. X squared plus 2x plus 1. Okay. Let me go through another one. X plus 2. This is x squared plus 4x plus 4. And if we go through x squared plus 6x plus 9. Accidentally, this is our equation here. But what I want to show you here is that this is 2, this is 1, this is 4, this is 4, this is 6, this is 9. How can we make sense of it? And then how we can connect this with this one. Okay. So every time you have this, it means that it will be a complete square if you can at least square root of this 9. This becomes 3, and then multiply by 2, it becomes 6. So it's become the perfect square. Okay. So you know that this will be x plus 3. How we can get 3? 3 is from 9, okay, or the positive one of it. Okay. And then we check, multiply it by 2, it becomes 6. So 3 is our complete square, right? Or our perfect square. But it doesn't need to be like this is just easy way to look at, but it can be also if we try to make out, like for example, we have x and y in one equation here. Okay. The best way to look at, I think you can do either using the table, like I mentioned before, and then maybe try to x, and then the other one is y. But if we cross multiply, it will be plus, so we need to make it minus. Okay. So I think this will be our perfect square for 2x minus y squared. Or if we look at, because we have 4x squared here, we can have some possibility of 2x, right? Because we want to make it squared, and this part here, this y is just y. So we need just to make out this 2x and y, and this is the answer. I think you can know from the first term and the end term. Okay. Okay, another thing in the factoring that is interesting is, let me just write x cubed plus x squared plus 4x plus 4. Can you factor out this? Can you factor this cube formula? Mm-hmm.
Yeah.
Let me give you two questions. X cubed minus 2x squared minus 9x plus 18. It's a little bit tricky to get the factors. So in finding the factors, I think after this part, after maybe 2 chapters after this, we will learn more about the polynomials and how to make out the factors from some using some division. But here, there's an interesting pattern that when you did this, let's make this 2 like this. Okay, let's make out this factors, the common factors from these 2. Okay, and then this part is this. Okay, and then this becomes x squared plus 4 x plus 1. Okay, we can also make this. So some of the polynomials can be grouped. Okay, can be grouped, and then you can factor out the group, and then maybe from there you can find another pattern that can be also factor out. Okay. In the same way with the second one here, we can take group here, take group here, and then we can take this. And then we can have x squared minus 9, x minus 2. This can be factored out one more time. For this x squared plus 4, we just stop here, right? It's called the quadratic factors. Okay. You will see another terms, quadratic factors, in if you take calculus 1, you will see later when we have some technique in integrals. Okay. Okay. My writing is too small. Let me write here for the next part here. You can also write the algebra in rational expression as something you're familiar to see, etc. Now let me introduce you to domain. Domain of the algebra, let me write of the algebra, the algebraic expression is set of real numbers that the variable is permitted to have. Okay. Now previously we deal with writing the variable in terms of some expression, some formulation, some equation, usually with terms x, usually, right, with terms x. And now we know that if we have this rational, we are having a problem with definition, okay? How the number will be defined, okay? How the interval will be defined. Like the rational here, the idea is because if we have 1 over x, we will be define this when x is not going to be 0, right? Okay. Or if you write completely, we can write with some notations that say x as x is not equal to 0. And then previously we also have the radicals, that is having a problem, right? When it's negative, we cannot define this in the real numbers. So we need to have some constraint or some restrictions that x is greater or equal to 0. So at least 0, okay? And from these two, we might have 1 over squared x, right? So we need to combine both. It's not 0, but it should be positive. So we could say that domain will be x as x, the intersection between these two. Okay, because if you just have a simple algebra, like before, like x squared plus something, blah, 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 well, of course, if we discuss about domain, the domain will be in everywhere, right? Not really have specific numbers that is going to be undefined, or maybe something happened there. But if we have rational expression like this, or radical one, the square root, we need to have some restrictions. And that's how the finding the domain becomes important if we have this kind of problem here. Okay? Let me show you how to solve some problems. Okay, let me go through the next one. So if we have x finding the domain. So before we talk about function, we need to talk about the domain. Okay? We need to talk about domain of some equation. So first is this, and second is square root of x over x minus 1. So I think the first one is not really complicated. So the first thing is because we see the denominator has some algebra, some algebraic expression, or we can see that this has a quadratic equation. First thing we can do is can we factor this expression? Okay. That's the first thing to do. So I think it's easy. X minus 2, x minus 3, right? Easily getting plus 6 and negative 5 when we adding these two. So from here, we only know that when we have 1 over x, x should not be 0. So this x minus 2 should not also be 0. So this is going to be, the domain is going to be x, as x is not equal to, or we can write or x. Okay. If you would like to write in more classy way, you can also write that x is a real number, but we don't really need to write the last one. The important thing is we write this too. Okay. Okay, the second one, we have square root of x, and we have a denominator that is x minus 5. Okay. The first thing, we can define this become two sets of domain if you would like. First thing is we have the square root of x, then x should be positive or at least 0, or we can write that x should be this, right? But the denominator x is not equal 5. So we can say, we can combine these two expressions, that we can write the domain as x greater or equal 0, and x is not equal 5. This is finding the domain. There are some parts that I skipped because I think we can. Yeah, I think we can skip this part. Now, if we have, for example, 1 over 1 plus square root of 2, we still say that this is not a standard. This is, we need to rationalize. Need to be rationalized. And how to do that is basically, because remember, when we have a minus b and then a plus b, we multiply this, we get the a squared minus b squared, right? Now, we have 1 plus square root of 2. What we are going to do is we need to change the form at the denominator. We remove the square root. One way to think is we need to, at least, if we have this plus here, like this plus b, a plus b, we need to multiply with something that has minus, but with the same component. That's how we are going to do this. Okay? So we are going to multiply this, the denominator, at least with this. And of course, the top will be the same, because basically, we're just changing the form, not changing the value. Okay. So this will be going to be 1 minus 2. And this will be 1 minus square root of 2, or we could say this is going to be negative 1. So the whole thing will be defining with negative 1. So we will have square root of 2 minus 1. Okay. But rationalizing is not only rationalizing the denominator because it's not standard. Sometimes when you try to solve some problem, you need also to rationalize the numerator. It depends. Okay? You can rationalize the denominator, or you can rationalize the top one, okay? The numerator. Okay? But the idea is still the same. What you need to multiply is, we call the conjugate. It's conjugate. Okay? So if you have 1 plus square root of 2, we need to multiply with the counterpart is 1 minus square root of 2. Okay? Yeah, I think that part, rational expressions. I think linear equation, not a problem, I think. I think quadratic equation also not a problem, right? Quadratic formula still okay, right? Just to make sure. Still okay, or need to have just, I think just a few expression and then we can skip the others, okay? Okay, now we have linear equation. Okay, this is when the terms is the degree is just 1. So I think not really having any problem, I think. Like for example, 7x minus 4, 3x plus 8, and then just to grouping all x and then all the constants, and you know that this will be, I think, easy enough, right? So I don't think this is important. The second part will be the quadratic equations. Let me just write the important things here. Okay, the definition. And how to solve is basically what we did before. Usually it can be factorized. We are going to use the factors. Okay, if you want to solve this, let me write solution is, the first thing is we make out the same to the left left side, and then we factor out as usual. I think it's not too difficult here. I think I will just go directly, and this will be 8 or 3, right? So we'll have plus 8 minus 3. And we say that solutions will be x equal negative 8 and x equal 3. That's the solution numbers that we are going to see. And another important thing is if we have x squared equals c, c is any real numbers. If we want to find this, we need to write both possible radicals with positive and negative. And then the perfect square, like we mentioned before. So if we have, for example, x squared plus bx, okay, to make it perfect square, we're going to add b over 2 and then squared. And then we can say that this whole thing will be x plus b over 2 squared. For example, if we have this, 13 is not something that you can factorize easily. We have only possibility 13 and 1, right? And to make it into 8, I don't think it's possible from 13 and 1. So we need to think another way. Another way that we can think is the perfect square. Get the perfect square. So let me write x squared minus 8x. We need to add with the how to complete this square. So we need to divide by 2. It's 4 and then squared plus 16. Okay. So if we write plus 16, this is going to be a complete square. And then we still have 13. So 13, let me move 13 to the left, to the right. So negative 13. And we need to also add with 16. Okay, why we need to add 16? Because the left side we add plus 16. Of course, the right should be added with 16 also, because we need to make sure that this is equal. Okay. The left part then becomes x plus 4 squared, and the right part will be 3. We can square root both sides. We'll write here square root. Now this will be plus minus square root of 3. So x will be 4 plus minus square root of 3.
X minus 4.
Oh, here. I'm writing down here.
Yeah.
Because it's minus 8. Okay, minus 8. Okay, now try another questions. for this one. 3x squared minus 12x plus 6 equals 0. Maybe any questions about this perfect square? I know some of you looking, one or two students looking a little bit confused on this perfect square. Any confusion? No? Okay. Okay, maybe something to be taken as a note, probably. The perfect square or any equation that you might encounter in mathematics or in calculus, basically when you deal with some equation, you need to have a reason why you need to plus or minus with something. Okay? If you just add out of nowhere, just add, like for example, this part here, I'm adding plus 16. Can I do that? No, unless I add both sides plus 16, because it will be the same thing as the original question, right? If I only add plus 16 on the left and the right, I don't add any numbers, then it will be very very absurd. Why I'm adding this plus 16? From where? Why? What is the reason? That is important. So when you deal with some questions, when you maybe multiply something, adding something, or maybe you find with some method, you need to understand why I'm using this and why I'm adding this. Okay, that's one way to make your logics can be understandably explained. Okay. Okay, now back to the second question here. What we can do from here, divide by 3, okay. All divide by 3. Yeah. So becomes what? X squared 4x plus 2. And then complete the square like the first one. Okay, it's okay. Let me move to here. Okay. So the last part will be added with plus 4. This is also plus 4, right? So this will be x minus 2 squared. And this will be 2, right? Yeah, good. So this will be square root plus minus 2. So x will be minus 2 plus minus square root. Yeah, good.
Why minus 2 if it's what?
Oh, yeah. Good, good. Just try your, I'm just testing your phone. But it's my mistake, actually. I didn't write fast. Okay. Okay, let me move to the other formula that you are, I believe, really familiar with. Let me just write with the ax squared plus bx plus c. It's a standard quadratic equation. Okay. First thing, let me divide with a, or multiply with 1 over a. This will be x squared. This will be b over a x, and this will be c over a. Right? And then, I forgot equals 0. And then let me move the c over a, move to the right side. And then like we did before here, we are going to make the complete square of b over a. So b over a divided by 2 and then squared. That will be going to be the next terms, right? So let's just add with that. So we are going to plus with b over 2a, right? We divide by 2 and then squared. And we do the same thing over here. Okay? Now this, we can write x plus b over 2a and then squared. Okay? Now, we can also write here, this b squared, we can write as b squared over 4a squared, right? And let's just add with minus c over a. Well, let me write on the right side here, just to give you illustration. So we will have 4a squared minus 4ac plus b squared, right? So we can write that over here. Okay. Now, let's square root this 2. Okay? This will be x plus b over 2a. This will be plus minus square root b squared minus 4ac. Let me write b squared first. And then 4a squared will be going out of the square. This will be 2a. Okay? And then I will move this b over 2a here. So we will have x is b becomes negative b plus minus. Okay, it's become something that you already know, right? The formula for quadratic equation. Okay, quadratic formula. So it's just actually playing with the complete square from the ax squared plus bx plus c, divide all by a, make complete square, and you will find the quadratic formula. So even you don't need really to memorize this. Okay, but I think you already memorized, right? I also, back when I still young, I memorized all the things, and I know that why I'm memorizing this. Okay, I believe it's quite powerful for most cases in quadratic equations. You can find easily the roots, right, or the x from the quadratic equation. You can find the solutions easily. But what I want to show you here, what needs to be emphasized, is the terms inside the radicals, the square root. Okay? We call this discriminant. Trust me, when you learn this basic of math, we learn this discriminant. When you learn later in calculus, you will also see this discriminant. When you learn in engineering of math, you will also learn this discriminant. Okay? So this is very fundamental, but yet it's going to be really advanced later on. Okay. So from here, okay, let me just write some simple explanation for discriminant. If d for discriminant, if d is positive, okay, which means we can get inside the radicals because it's positive, we can just adding as usual. We know that this will be having the solutions that is two distinct real solution. Okay. And if d is 0, well, you can imagine d 0, which means we can erase the whole thing, the square root, right? So the answer is just minus c over 2a. So it's only one solution, right? Okay, only one solution. One real solution. And if d is less 0, no real, right? It's imaginary. So we can just write no real solution. So if the question is just asking how many real solutions or what kind of solution that it might have, you can also just see from the square root, or just b squared minus 4ac. If it's a positive, then you have two real solutions. If you have 0, you will only have one real solution. If it's negative, then it means no real solutions. Okay. 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 Uh, Let me wait for a couple minutes. Another type of equations that might be in um, our content or our chapters is if we have some fractional expressions, but it's a quadratic equation, but it has some fractional expression. Let me show you some examples. Okay. This is the first one. The second one, let me write here a little bit, right? Second one is if we have a radical. So let's say 2x. So we are going to continue, okay, and then no break for now. We may finish early. Do you guys have lecture tomorrow morning? No? No? Anyone have lecture tomorrow morning? What lecture? Physics? Okay, now the first one here, let me make it a bit closer. It has the fractions. Well, I believe one way is we combine the first two fractions, right? And then we have some combination of the denominators, right? And then we can just try to solve, right? But another way to think is, because if we see this x squared minus 9, we have the factors of x plus 3 and x minus 3. Okay, at least we have the same x minus 3. So to remove this x squared minus 9, okay, I think we can multiply, let me write here, both sides. We can multiply both sides with x and x squared minus 9. If we do this, then we are going to have, this is 3, canceling the x, and then we have x squared minus 9 for 3, and then minus 2. We have x plus 3, so x, and then x plus 3. And then this will be negative 12x. So we are going to have 3x squared minus 27 minus 2x squared minus 6x. X squared plus 6x minus 27. Or if we can factorize, this is x, 3 and 9, I think 3 and 9. 9 will be positive. So we will have, x equal negative 9, x equal 3. But because we have these fractions here, we know that the domain, right? We have some restriction on domain. We need to check, okay? Check these two answers. Check solution. When x is equal 3, the left sides will be 3 by 3 is 1. Oh, something will be happening with 2, x minus 3. This will be undefined here, right? So this is, I think, not our solutions. But when we check the x equal 9, I think not a problem at all. We can solve the solutions. Okay? So we say that this is our solution. Solution is only x equal 9. Or negative 9, sorry. Negative 9. Okay. So whenever you have a fractions, a rational, remember the domain. Okay. You need to check. So check the solution whether it's on the domain or not. Now if we have these radicals here, the principle is, if you want to find the solutions, is removing the radicals by squaring the radicals itself. Okay. Okay, now to make it easy, we can move out 1 to the left side. So we only have this negative 2 minus x, like that. Then we square this both sides. We will have 4x squared minus 4x plus 1. And then this will be just 2 minus x. And then we can, plus x is negative 3x minus 1. Okay, now we can make the table again, if you'd like. And then start maybe 2x, 1, negative 1. I don't think this will be the answer. The possible number should be 4 and 1 to make it 3. This will be negative 1, 1. Okay, it's negative 4 plus 1 is negative 3. Okay, so it's correct. So this will be, the factors will be 4x minus plus 1, sorry, and x minus 1. So x will be negative 1 over 4, and x will be x equal 1. Again, we need to check. So check solution. Because we have the radicals. This square, let me write the square root of 2 minus x. And let me write the complete equations. Let me write here, maybe let me write here. X is negative 1 over 4. 2, negative 1 over 4, 1 minus 2 plus 1 over 4. This will be negative half. This will be 2 plus 1 over 4 is 9 over 4. It's 3 over 2. So 1 minus 3 over 2. It's true, right? It's correct. It's correct. When x is equal 1, 1 minus 2 minus 1. This will be a trouble because this will be 0. And this is 2. So problem with this. So it's not satisfy our equation. So the only solution is okay. Now we give you another question. X with power of 4. Okay. Find the solution. Now we have a equation with degree 4. Okay? With degree 4. How to find a solution? How to find a solution? Now, one trick that can be observed immediately is if we can make this somehow just as our standard quadratic. If we can make it like a quadratic, then we still can solve this and we can still factor it. Okay? So first thing is, let's just see that if we can make out this, we can make this, right? We can make the x with power of 4, which is just x squared and then squared, okay? Which means if we can make out this x squared as another variable, is another unknown. For example, let's make this as a. Let the x squared is just equal a to simplify our equation, to simplify our computations. So we are going to see that this is going to be just an ordinary quadratic equation. Okay? So we can try to solve this. Can we factor? I don't think we can factor because 8, 2, 4. So at least we need to have a 6 in the middle, or a 1, 8, maybe 7. But it's negative 8. So let's maybe take the perfect square or go directly to the quadratic formula. But let me just take the complete square. A squared minus 8a is negative 8. So we need to plus. Divided by 2 is 4. 4 squared is 16. So we are going to have a minus 4 squared. It's going to be 8. A minus 4 is plus minus square root of 8. A is 4 plus minus square root of 8, or 8 is 2 square root of 2, right? So we can write this. But this is not the final answer, right? Because it's still a. What we are going to find is x. So we need to find the original variable. So a is x squared, right? Yeah, x squared. So, which means this is a. So this is x squared is 4 plus minus 2 square root of 2. So x is plus minus 4 plus minus 2 square root of 2. So we will have 4 solutions. Okay, we will have 4 solutions because we have plus minus and plus minus in the inside. Okay, so we are going to have x is square root 4 plus 2 square root of 2, and then the negative part of it, and then we have the minus, and the other part. Well, if you want to find the decimals, you can compute with calculator, but I don't think we need the decimals. So just this answer is okay. Okay, maybe any questions? Anything to discuss? No? Okay. Okay, the other is x with power of 1 over 3 plus x 1 over 6 minus 2 is equal to 0. This is minus So now we have a rational exponent. It's in our equations. The principle should be the same as the left one here. If we could somehow manipulate the equation and makes the equation as normal quadratic equation, that's the principle. Okay? So before you try something that is really complicated, maybe we can take out with our quadratic. Maybe we can manipulate this equation into our quadratic. Okay? So we have 1/3 and 1/6. We know that 1/3 and 1/6 is basically half. We multiply with 1/2, it's 1/6, right? So if we have 1/6, if we squared, we just multiply, right? 1/6 with what? With 2, multiply becomes 1/3. Okay, so let me just go ahead. Let me just. So if we have x with 1/6 as the power, if we square this will be x 1/3, right? So if we could make somehow this x with power of 1/6 as another variable as we did here. Let's say we have a or b. Let's say b, to distinguish from the previous one. Let's say this is b. Let the x b. So the x 1/3 becomes b squared. Okay. Now you have b squared plus b minus 2 equals 0. I think we can factor it. 2, 1. Okay. I think we can factor it. This b, and then -1 and +2, okay, to make the product. So we are going to have b equal 1 or b equal -2. But it's still b. We need to make x. Okay. So this will be x 1/6 is 1, and it's just 1. Okay. Easily we can say that. And the other part, this is going to be -2. And now we need to make the exponent here -2 with power of 6. It's 2 by 2. 2 by 5 is 32. 32 by 2 is 64. And since it's even number, we just have a positive 64. But again, why is b is x? Sorry. Okay. But again, these two equations here, we need to also check with the original one. So let me write the original one. X 1/3 plus x 1/6 minus 2 is equal 0. If we check 1, I think 1 is okay. If we check 1 is okay. If we check 64, let me write 64 here. 64 plus 64 minus 2. This is 2 by itself, we already calculate, but this is going to be cancelled out. So it's not a 0, right? It's not a 0. So this x equal 64 is not our solution. Solution is only the x equal 1. Solution on the x equal 1. Okay, one small note on what possibly happened, another equation, is with the absolute value. So another equation that's possible is absolute value. With this absolute value means that there will be at least two possible expressions, positive or negative. Or in our case here, we can write down that we can have 2x minus 5 equal 3 or 2x minus 5 equal negative 3. And in both expressions, we can find each solutions. And both solutions are correct if you check through the equations. So solutions are x equal 4 and x equal 1. Or another way to look at the absolute value is we can think this absolute value in two different ways. So first is all positive like that, and the second is multiple with negative. But in my case here, I'm multiplying the other side, which is the same thing. Okay? Okay. We'll skip some part. Actually, the next part is supposed to be complex number, but I will skip for now. Maybe later on, when we have time, we can introduce the complex number. Okay. Next sections, probably the inequalities. Okay. And then after this inequalities, I think I just showed you some parts, and then we can finish our class. So inequalities. Okay, when we deal with something like 4x plus 7 less equal 19, what we are going to do is this part, the inequality symbol, we can cover first and just think that like just a normal equation. Okay? Let's just think like normal equations. Let's just write 4x plus 7 and then equal 19. Okay, let's just write this first. Okay? And we want to find the x. I think we can find easily. And we know that this will be 12 and this will be 3. Okay? So if we draw our line number, and this will be important for the line number, or in any inequality. Now let's say we have 3 here. Okay. Now if it is just a normal equation, then our answer should be the solution in the real line is just this 3, right? Okay. But now, since we have this less equal, if we change all with the less equal, then our answer will be all that x less equal 3. Okay. This will be our answer. Well, if you just maybe not really looking at the real line number, but looking at this equation here, you could say that, oh, it's easy. We can just change this all through this inequality. Well, we can't do that because it's just a simple equation. It's a simple equation. When we deal with more and more complicated one, we have the quadratic, or we may have the rational equations, and so forth. My suggestion: treat the equations as normal equations without any inequality. Okay? Just to know which x that should have been in our line number. Okay? And then we can think on domain. We can think on the positive or negative signs that we are going to achieve. Okay, but that will be later part. But this is intro. Okay, if we have 3x less than 9x plus 4. To find the solutions, first thing is we just try to move out with the same terms. Try to add and subtract. Or probably, if we're looking at here, we can think this 3x minus 9x, okay? And then 9x, this would be minus 9x, and then plus 4. So we get directly negative 6x less than 4. Now in inequality, if you want to make this x positive, meaning you multiply with negative 1, or negative 1 over 6, so then we can cancel the 6, then this will be x, and the inequality will be changed to greater negative 2 over 3. Okay, and then if we want to make this interval in the line number, and to check whether our answer is correct or no, we could check this negative 2 over 3, and then check the number. Okay? Check the number. Check 0, check 1. That is easy to follow whether it is true or not. If we check 0, we can check through the first equation here. Okay? The first equation. If we check 0, it's true. It's 0 less than 4. It's true. If you check 1, it's true also. But if you check, let's say, negative 1, maybe here, negative 1 here, negative 1, is it true or not? We can check, and we may write a line number as our solutions that is going to be here. Well, anyway, line number is to confirm that our answer is correct. Another type of inequality that might be in our discussion, it will be if we have two sides of inequality. So we have 4 less equal 3x minus 2, and then less 13. So to deal with this, we can think of two equations at once. Okay. The first one is this 4 and this middle equation, and the other part is this. Okay. So when we move out, for example, when we move out this -2, we need to move to both sides. Okay. So we need to move here. We also need to move here. So we are going to have, this is going to be 6, it's plus 2. And this will be going to be plus 15. And we can simplify, divide all by 3. So, well, wait, not equal. So we have 2, 2, 5. Or in our line number, we are going to have, this is 2, 2 is included, and 5. It's open. So we are going to have precisely at this middle. Well, we could check. We could check with 0 and 6 if you would like. I think if we check with 0, it's become negative. We need to have a positive between 4 and 30 if we plug into the original equation. Okay, I think we'll stop until here, this inequality. And I have 3 simple questions that I just want you to follow. So, and at the end, there will be attendance. Okay, attendance. Okay, so if you would like to write some notes here. Okay. Okay, I think I will stop the sharing. Okay, and then let's see. Yeah, you can join through QR code or go to the websites, menti.com, using the code 19504658. And sure, because this is the first time I'm teaching at night class. I'm not sure whether you like studying at night. I'm not sure. Maybe you have done before, like taking night class. Because I think the department, they want me to to teach as many as possible. So the only way they can fix the time is the night time, which is not really ideal for basic of math. But I'm not sure whether you like it or not. But if not, I know that you need to go home like earlier, blah blah blah. So maybe my thinking is maybe some parts of our lecture, maybe some chapter, maybe we can done it online. What do you think? Okay. Some part that really need to have like some exercise, maybe we can do at class. But some part that is just like story, narrative, and then just some simple formula, maybe we can do it online. What do you think? It's good? Okay. Hmm? Mm-hmm. Yeah. Sure. I will maybe put in the Moodle like what schedule like we can do online. I think for next week, because we're still at the early part, we can do online, okay? But maybe next 2 or 3 weeks, maybe we can go into the class for some exercise, okay? I think that will be okay. I think for everyone, especially if you have morning classes tomorrow, right? Okay. Okay, I think already a lot. Colette, let's start. Okay, let's start. Okay, I have 4 questions, and the last part will be for the attendance. So please your student ID, so I can also make sure that you can have grade for your bonus activity. Okay, I think we can start countdown. Okay, 3, 2, 1, let's start. This is just the question, and then just true or false. Maybe too fast, only 30 something seconds, but just testing whether you can think quickly. Irrational number. Okay, I hope you still remember what irrational number means. It's perfectly half. Okay, it's perfectly half, but it's false. Okay, it's not. It's false. If you have pi, you have negative pi. If you combine, it becomes 0. Right? Okay. Okay, next one. Leaderboard first, just to motivate who are the winner. Okay. Okay, get ready for the second question. Okay, 3, 2, 1, let's start. Second question. I also forget the questions. I think you need to see it in your phone. Okay, good. Okay. Natural number is numbers that came in nature that you can count 1, 2, 3. It's nature, right? Okay. Okay, next one. Okay, still the same student. Okay, 3, 2, 1, question 3. Okay, I also forget the question. Oh yeah, okay. Yeah, you need to think very quickly. 20 seconds. Okay, good. Remember, the radicals have plus minus. Okay. Okay, the next one. Next one. See. Oh, is it going to be change? Oh, it's changing. Okay. Okay. Next one. Question 4, last one. Okay, you need to do some math. Less than 1 minute. You can look from the form on the options. I give you the options, which means that is a possible answer, and then thinking how to get that. Okay. Okay, last the leaderboard and the attendance for you to write on. Okay. Who is 33? 33? 33? Your ID also 33? Okay. Okay. Now the last one. Yeah, for the attendance, please write your student ID and maybe anything to discuss, suggestions. You can write multiple times if you have many suggestions. Also okay. Because I think the problem I have with this lecture, with the course, is just the night time. I know this is supposed to be your time for relaxing. Okay. Okay, if you have written your student ID, I think we can done and you can go home. Okay. You already have written here. And for the online students also, if you have done, then I think you can also leave the meeting. It's okay.